A with the subscript minus k is the same thing as A with the subscript cap k here. And the reason is because A is an even function. And then minus I is still here. If you replace B minus K, it is the same thing as negative B of K. And the reason is because the function, the coefficient B, we proved to you earlier that B is an odd function. And then divide by 2. So we can see clearly this minus sign here with another minus sign there, so become plus. And therefore, equation 37 that you have here will become equation 38. So in other words, we have the definition C naught equal to A naught according to equation 35. CK tilde definition is given by equation 36. And C tilde minus K, the definition is given by equation 38. So if we substitute equation 35, equation 36, and equation 38 back into the previous formula, which is equation 34, okay? Substitute those equations in equation 34. Then, based on the new notation defined in equation 35, 36, and 38, what we have is the Fourier series can be expressed in this form. The Fourier series can be expressed in this form. Now, then we will begin to play a little small trick in here. First thing we say is this. This term and the summation term together can be combined as this summation sign. And the reason is because the subscript k, instead of going from 1 to infinity, here it will go from 0 to infinity. So that way the effect of the term C naught is already included in this new summation here. Because if k is equal to 0, if k is equal to 0, then what you have is C naught, C tilde naught term, which come from here. Okay? Now there's another term, there's another trick that we can do. This summation right here, instead of saying k go from -1 to infinity, we say it go from -infinity to -1. Alright? Nothing is changed. And then the advantage of doing that is what? Oh, by the way, just in case you want to find out how come this term right here, the second term right here, why does it become this term in here, just in case you want to find out why. And the reason is very obvious. The reason is this. You can say this term in here is the same thing like saying summation k go from 1 to infinity of C minus k tilde E minus I k omega naught t. Right? That term is right there. If you replace k by minus k, if you replace like that, then this summation will become k from minus 1 to minus infinity. And then c tilde minus k, if you make this substitution, it will become c tilde plus k, and then e minus k become plus k, and then omega naught t. And this is exactly this term. That's exactly this term. So now you can see the first summation, this term is here. The second summation, this term is here. And therefore you can combine these two terms together. The reason, because the thing inside the summation sign, for both terms they are the same. So you can put it the same thing in here, in equation 39. And the only difference is the summation here go from minus infinity to minus 1, and this one go from 0 to plus infinity. And when you combine together, it becomes minus infinity to plus infinity. Okay? To help you understand better, let me show you a picture here. Let's say this point right here is minus infinity. Let's say this one in here is minus 1. Let's say this term in here is 0. This thing here is plus infinity. And the x-axis, the horizontal axis here represent, for example, k. You see? So the summation go from minus infinity to minus 1. That basically represent in here. And the summation from 0 to infinity is representing here. And therefore, when you combine the two together,